Hey, let me tell you something that's going to completely change the way you're thinking about the current timeline, and it's actually going to make you appreciate it a lot more than you currently are. See, at the moment, scientists around the world are competing for one common goal, and that is achieving world's first self-sustainable nuclear fusion reactors and creating the world's first nuclear fusion reactor. So, let me quickly explain you why is this such a big deal, how it works, and why this could be the world's greatest scientific breakthrough in history. See, you can say that we already have nuclear energy, and you're correct, we do. It's happening in our nuclear power plants, and unfortunately also in those things that are supposed to fall from the sky that rhyme with your mom. But that is achieved through nuclear fission. We basically split the atoms inside of nuclear reactors, which creates an enormous amount of energy, but on the flip side, it can also cause quite a bit of radiation, and in some unfortunate cases, you can have a runaway reaction, which if you don't stop it at the beginning, you can have problems like in the Chernobyl. So the forever question was, how can we make this significantly more powerful, but also significantly more safer? Well, the answer to this problem is nuclear fusion. It's what's happening in the stars, like in our sun, and works exactly opposite from nuclear fission. Instead of splitting the atoms, you're merging them together, which creates significantly more power, but also less radiation. And the best thing of all, as soon as you cut the input of energy, the whole reaction stops, thus significantly safer. Now, the million-dollar question is, if this is so much better and so much safer, so how come we haven't been using this thus far? Well, the problem is, achieving this is far easier to say than actually doing it. See, in order to achieve this, you need enormous temperature, but also enormous pressure, which can be achieved naturally in the sun, but there's no way that we can do that on Earth. See, the pressure part is out because we would need something as big as the sun, and the temperature is out because there's no material on Earth that can possibly sustain that without melting instantly. Now, let's for a moment focus on the temperature part. What if you build a chamber, you surround it with very powerful electromagnets that create magnetic field which would keep that plasma in the middle of the chamber, thus not touching the wall. This solves the direct contact problem, but you still have the air around it, which works as a medium, heats up, transfers the energy, and you still end up with molten walls. Now, the answer to this problem is actually pretty simple. You just suck the air out of it, you create an airtight environment, aka the vacuum, and problem solved. And this is exactly where the physics helps you with the pressure part. See, whenever you heat something up, the atoms inside start moving very, very fast and colliding. And when you heat something up to millions and millions of degrees, well, you create pressure. Pressure enough to sustain your nuclear fusion. Now, this is a very simplified explanation of how it actually works, but these are the basics, and once this is achieved, the world will be powered on nuclear fusion for the most part. Now, if you want to know how mind-boggling this is, well, I'm just gonna leave you with this. If I was to ask you how the world's gonna look like 5,000 years from now, there's no way that you can possibly even begin to imagine, because 5,000 years ago, they were building pyramids. But there is one thing that you can bet your money on. 5,000 years from now, the world will be powered by nuclear fusion. Thanks for watching, and if you want to hear more from me in the future, like, share, subscribe, because every now and then I say something smart.